Hello everyone, welcome to your next class. Today we are going to extend our knowledge of statistics and introduce the concepts of variance and distributions, normal distributions to you. So we're going to recap a little bit on what an average is, because averages are really important when we talk about variance and standard deviation. And then I'm going to introduce you to one of the most common probability models that exist. They're called normal distributions. You probably recognize them as bell curves. Another word for them is a Gaussian distribution. So why don't we just jump into it so you can see what I'm talking about with all this. So today you're going to learn about what mean and standard deviation are. Also what variance is as well, because variance is kind of like standard deviation. And then we're going to teach you what the normal distribution is all about and how the dynamics change, or at least the shape of a distribution changes, and the probability of results change given given a different standard deviation or a different mean. So we're going to see how the shape of this bell curve adjusts when we adjust parameters that are used for it. So first off, what is a standard deviation? So a standard deviation is a normalized form of variance. Variance is how much numbers are spread between the average. So if you have an average and all of the numbers are very, very close to that average, you would have a very low variance. They don't vary from the average that much. If the numbers are very spread apart from that average, you would have a high degree of variance. So what a standard deviation is kind of a way of normalizing all of that, so that a standard deviation of 1 always means that a certain proportion of your values are above or below it, okay? So you can think of standard deviation as a form of variance a standardized form of variance that we use to look at shapes of distributions more or less easily. The next thing you're going to learn is what a normal distribution is. So you all know what normal distributions are. You experience them every day, or you probably experience them very often, maybe not every day. But this is the bell curve. This is that common looking bump shape that we see when we talk about school grades and other a lot of things. So this is the normal distribution was first formalized by a guy named Gauss. So it's sometimes called a Gaussian distribution. And the most amazing thing about this distribution is it occurs everywhere. It's in nature. It's in science. Like we see the normal distribution is one of the most commonly occurring distributions, statistical distributions that exist. So understanding how this distribution works makes it really a lot easier to understand how all the other ones work, because this is such a general, simple, and commonly seen approach to probability and statistics that it's really the most important jumping off point for understanding this stuff. Okay, so we're not going to have a typical syntax section for this tutorial. Instead, we're going to just look at an interactive graph, an interactive normal distribution, so I can show you how the dynamics of it change. So let's just hop into that now. There it is. That's not it. There we are. Okay, so in this graph, what you're seeing is this is just a website that we've gone to for looking at the normal distribution. I'm going to just scroll down a little bit here. Here is in fact what a normal distribution looks like, this blue line. And we have some red dotted lines and some green fill-in shade stuff. You'll also notice that we have these sliding points here that you can play with. So if you want to go to this yourself, you're more than welcome to. So the first thing I want to show you guys is the nomenclature that we use in statistics when we talk about means and standard deviations. First off, this is the symbol we use to describe mean in statistics. It kind of looks like a U with a little thing at the beginning, or a funny shaped M. This is the Greek symbol mu. So when you see this symbol in statistics or any other reading that you do when you're doing probabilities, this means the average. This next symbol here, which looks like an O with a thing attached on the right-hand side of it, this is the symbol sigma. And sigma represents standard deviation, which is like a normalized version of variance. So what I want to do with you guys is play with this interactive graph a little bit. So the first thing I'm going to do is I want to just set this to just some easier numbers. First, if you play with this yourself, you'll see that the shape is changing. That's because I'm changing certain parameters. So what we have here is a graph. We have an x-axis that's going from 0 to 10, and a y-axis that's going from 0 to 1. The x-axis is representing, this could be anything. We don't know what the data actually is, but let's just say for now that it's scores, okay? It's like a test. And the average value, or the average score of a test, let's say it's, out of 10 or something, was 5 out of 10. From this, you can also see we set a standard deviation of 1. What that ends up meaning is how this graph is going to change in terms of its shape. The y-axis here is proportion. So if we had a bunch of people that took this test, what we would say is that at the average, on average, about 40% of people scored an average result. Okay? In normal distributions, what this also means is that 50% or just under 50% of people scored under the mean, and just over 50% of people scored over the mean, okay? And that's what this line sliced down the middle is representing, okay? So if we summed up all of the values to the left of this graph, it would equal 40%, like the amount of people that followed under this graph. And if we did the same for the right, it would be the same. But we have 50% on either side, okay? That's how this distribution works. So we have a standard deviation of about 1 here. So what that ends up meaning is that once we get to 6 out of 10, about 25% of people would have scored above 1 standard deviation, meaning that 75% of people here scored less than a 6, a standard deviation above the mean, okay? And if we have 2 standard deviations, everything that is to the right of this second dot here would be about like 2.5% to 5% for standard deviation either 2 standard deviations above the mean or 2 standard deviations below the mean. So next I want to play with how variance changes the general plotting and distribution of values within this normal distribution. So what would you expect if I shorten the variance, meaning the values are closer around the mean than if they were a higher variance? So they're distributed more towards the mean. What would we expect to happen to the shape? Would it get flatter or more pointy? Well, it gets more and more pointy as we get closer to the mean. And that's because more people are just scoring in that range and they're not scoring outside of that range. Okay? This is with sigma at about 0.25. What happens if we make the variance larger? Well, this is going to start to flatten out because everyone's getting very, very different scores. And you'll see as it kind of starts to become asymptotic around 5. So this will start to flatten out. Okay, so what this is demonstrating is how variance changes the probability or the distribution of scores around that mean, okay? And let's just bring that back up to 1. What would we expect if we changed the mu, if we changed our average value instead? Would we expect this to become more pointy, more flat? All it's going to do is keep the shape, but shift where the center is. Shift where, where the top of this value is going to be, okay? And that's just playing with mean there. So, okay, guys, with that, I think we're going to call this at this point. The point of me showing you this was to show you what a normal distribution looks like and how, if you adjust parameters, how that distribution changes, and getting you familiar with these y and x axes, okay? So, what did we learn today? We learned about how standard deviation works, that it's this converted measure of a variance, and that 1 and 2 standard deviations mean that a certain percent of the population should be above or below that score. And that's why the normal distribution is so effective and useful when dealing with test results, for instance. We then played with the dynamics of this distribution, meaning we saw what happened if we increased and decreased the variance and decreased the average, and how that impacts the shape and how we might actually approach analyzing it. Thank you very much, guys. And in the next section, we're going to do a couple of types of statistical analysis. So we're going to put this all together and do a t-test and maybe another type of test, depending on how far we get. So very exciting, and see you in that last section.